Hello and welcome to another video of this video series of myself looking at companies from the space of quantum communication, quantum sensing and quantum computing. In today's episode we are looking at a company called QBLOX, and without further ado, let's jump right into it. So here I'm on their website now. We first of all, of course, allow all cookies. There is some information here about a webinar with MIT's Will Oliver coming up. We will not register for that for now. But what we will actually do is we will hop right into the topics here. So what do we see? Looks like something from the electronic space. I see a lot of green LEDs. There's a lot of connectors here. I think they are connectors. So I would guess from that we are looking now at the quantum signal processing here. So what usually happens in the lab. It looks like this could fit into a rack. And another thing that is interesting about it is that you have these single cards here. So it's like single slits that go in. So you can probably very nicely in a modular fashion assemble your own unit here. At least that's what I would guess if I see those screws and also my background and working with something similar in the lab. Now, there is nothing much else on the starting page, so there's nothing where you can scroll down or up. There's a banner down here which says research. There is another in here which says industry. Also, there's different animations here. So if you do research, you see very much what I just said before, like you can assemble them, you change the configuration of different units that you want to have in there. If you hover over industry, you see you can also get multiple of those together to create a bigger system. Let's start with the research side of things. So here it says QBLOX cluster. So let's check that out. It's a fully modular system, as we saw before, fully customizable. And easily scalable system. Okay. QBLOX collaborates with leading academic labs to deliver a state-of-the-art quantum control stack. The modular cluster, paired with versatile software, incorporates all crucial electronics tailored for advanced quantum labs. It effortlessly scales for pulse generation, supporting extensive qubit counts ranging from single digits to thousands. The product lineup encompasses control and readout modules covering a broad frequency spectrum from baseband 0 to 400 MHz to the microwave regime 2 to 18.5 GHz, providing a comprehensive solution for quantum experimentation. So that's a lot of information in a short abstract. Let's quickly take this apart. So we see here it's a modular cluster, that's what we already said, with versatile software. So they also create software. That's good because you somehow need to control the hardware, right? It incorporates all crucial electronics. It's for advanced quantum labs. It says here, effortlessly scales for pulse generation. Pulse generation is, for example, what you need in order to operate on a qubit. So if you want to flip, for example, the spin from 0 to 1, you need to send a pulse to the system. That's what you can generate apparently here. But it also goes extensive. It goes. You can create multiple of those. But yeah, what I actually wanted to say is that I think I don't see it here, but like you can see here that one says readout and that one says control. So I would guess that besides the pure pulse generation, there is also some sensing in there, right? Where you can actually sense if the qubit is at a specific level, which you are using then for the readout, for example. Now, the interesting things to say here as well is that you have this, let's say, lower frequency band going from 0 to 400 MHz, which, for example, is relevant for all types of DC applications and whatnot. I don't know, tuning gates, whatever. But then you also have this higher frequency range, this microwave regime, this higher frequency gigahertz range, which you then actually need for like flipping qubits or whatever, right? Because usually that's the energy range that is relevant for these quantum systems to be operated on. Let's scroll down a little bit further. The ultimate control solution. So we see hardware, software documentation, tailored solutions for challenges in the quantum industry. So you see here fastest results, scale up to thousands of qubits, and customizable software stack. And we will check out all of this in a second, but first of all, let's see what else is provided here. So hardware, accelerate quantum results, qubit agnostic control electronics for world-leading quantum research and development. So there's the cluster and the SPI. Then it says here, you can now see it here. You have these single cards which you can pull out, put in. That way it becomes very modular. You can also scale it, right? If you only have, I don't know, 4 qubits, you might only need 1 or 2 of these cards. But then as you move on to 60, you might need, I don't know, 2 of these boxes full of cards, right? So it's like scalable, modular, and it's a complete solution, what it says here. Here we see different types of qubit technology, which I think they are catering with their products. So you have the superconducting technology, spin, as I guess in spin qubits. Okay. So here you see what the configurations look like in order to start working with those systems, I guess. Then we have the NV centers. We have, if you want 30 superconducting qubits, you need a full system full of that. 20 transmon flux tunable qubits. And I think that's very nice, right? If you have a single spin qubit, you end up with 1, 2, 3, 4. I guess that's the communication card, which sets up the communication with your PC. Then you have this one, which is a readout box, a control box, and a second control box. So you have these two to do the control. I guess one of them is for the higher frequencies and one's for the lower frequencies. And then you have the readout one, and you have a communication interface. Now, if you have 30 of them, you end up with something that looks like this as a configuration. And then, set up hybrid qubit looks like this. Okay, that gives us a feeling. Now we also get to learn what the different cards are. So you have the 0 to 400 megahertz for output, real-time control module with high channel density and ultra-low noise with nanosecond scale pulse parameter updates and seamless unification within the cluster via sync with Q, of course, and link protocols. Then we have the RF, so the QCM RF2, which is the 2 to 18.5 gigahertz 2 output system. Then you have the 100 megahertz to 10 gigahertz 6 output 2 input QCR. So I guess this is now doing both readout and control as to what it says here, right? Modular precise qubit readout and control with high fidelity gate operation without recalibration and seamless integration into the QBLOX control stack. Then we have here the QRM, which has 2 outputs and 2 inputs and 0 to 400 megahertz frequency range. Then we have here the single, so the QRM RF1, I guess, which has 1 output and 1 input. There is more, there's a QSM, so 28-bit resolution with less than 0.6 microvolt step size, 8 reconfigurable DC input and output. So this is now the pure DC. This I guess you would use to do some gate controls. And then we have finally here the QTM, which is a 20 picosecond readout, 30 picosecond control resolution, 8 digital inputs and outputs device, which you can see here is, for example, for photo detector readout, because if you want to do visions and NV centers, then you actually need something like this, which is more tailored towards the optical applications. Okay, that looks good. Let's see if we can also learn a little bit more about the software side of things here. So it says QBLOX software. We see some Linux interfaces or like terminals there. Control experiments on QBLOX hardware with Quantify, complete open source software stack. So Quantify is the software that they are creating. It's open source, which I think is very important for research for several reasons. Because first of all, as researchers, oftentimes do things for the first time, as they want to do new stuff. They need to have ways to actually manipulate the software stack and change it in a way to add functionality that maybe only they need for their experiment, and where it doesn't make sense for the company yet to invest into building all of that. But also, and that's something which I've been also promoting here on this channel before, for the researchers themselves, right? For the students, I think it makes sense to work in a lab that is using those open source software stacks, because you learn it once and you can then transfer it in your later career as a researcher, maybe also to another lab, right? Because it's open source, there's high chances that others might also use it, and you also can create visibility, right? If you, for example, commit something to an open source stack, if you get a merge request, whatever, if you work in the open source community, you can show that, okay, I'm not just a simple user, but I have a deep experience in, for example, Quantify. I don't know how this software stack is managed. I don't know the details. And yeah, there's more to learn about the different technologies here. I would like to actually quickly go and check out a little bit more on the software side. Like, is it a Python stack or does it work on something else? I'm not actually sure. Is there like so there's a product sheet, some documentation. Maybe let's check out the documentation. So it's an open source Python framework. Okay, so there we go. They have a Slack community to actually, I guess, ask questions, get into support. There's some about here, and if you click on the software side of things, yeah, it takes you there. Looks like there's even a YouTube tutorial series, so or at least there's a seminar which is on YouTube available about that. So go ahead and check that one out. You've seen it before on the screen. And yeah, there is some more information here. Here we see Chris. I actually know him. We've had the chance to, or the pleasure to actually work together before. And yeah, there's some more information here about the software stack. By the way, if you are actually using this software stack, or if you want to start using it and you need some help with it, I would also be happy to create a tutorial about that one. I've been doing that for QCodes previously on this YouTube channel. Happy also to take a look into that. If you're interested in that, let me know down in the comments below, and then we will create a video series about that. With this, let me very quickly hop back here and check out the industry side of things, because we haven't done so yet. And then I guess we will also get closer to wrap up already. So the QBLOX cluster, oh wow, that's a lot of devices. Now we see here an easily scalable solution, 3 racks full of devices, fully customizable, fully modular. You can book a demonstration here. I guess that's what you need to have, like what you need to create like a full-on quantum compute cluster with maybe even multiple fridges in there, right? So then I guess that's the solution that you're looking for, right? So the ultimate control solution, we're dedicated to the development of scalable control electronics, essential for the effective implementation and advancement of quantum computing capabilities. We see something here that we've seen before, which goes into, now the cluster side of things. So here we see scalable, modular, complete solution. Again, we see those different configurations that we've seen before and the single modules that go into it. Something more on the hardware side of things and the software. That's everything that we've more or less seen before. But let's quickly hop here into the menu side of things. So there is also some research linked in here. I guess that goes into like where these are being used in publications. Let's quickly see. No, not sure. Maybe down here. So there's some information about the people that are using it. Ah, no, this is industry and then research. Okay, that's what we've seen before, right? Oh, sorry. Then we've seen the products, some applications. I guess this is like, superconducting spin and NV centers. And Yeah, that's interesting. That's very nice also, by the way. Like, it also explains a little bit about the technology, like for example these superconducting qubits here, and I guess also what type of electronics you would use. Yeah, like for example here you have the QCM RF, so the one signal version, which sends a signal in, and then I guess you also read it back out. And then you have the sync and the link, which are the software interfaces to the QCM on the other side. And this one is, I guess, what is doing the proper readout here. So yeah, that's actually quite nice, because also as a researcher, you get an understanding of which building blocks do I actually need to assemble to be able to create a full setup that I need to do the measurements in my I don't know, spin system, for example, spin qubit system, or for NV centers like here with the optical detectors. By the way, if you want to have a video of me going through these different technologies, as in like what a typical setup looks like, what is actually the qubit in this specific case, how is it being controlled, manipulated, also let me know down in the comments below. Then we can do something on the different platforms, and I can make a little explanation video of that as well. Okay, then let's quickly check out also the About Us page. You know that I also like to always learn a little bit about the company itself. So here it says, meet our 150 plus members, team of scientists, engineers and developers. QBLOX operates at the frontier of quantum revolution, supporting academic laboratories worldwide. This is made possible by our passionate, dynamic and diverse team. With a dedicated team of scientists, engineers and developers, we are pushing quantum technology to support scientists and institutions worldwide with our scalable and low latency qubit control equipment. Then here you see, I guess, the founders of the company, or the C-level executives. Then we see here, I guess these are like some labs they are working with, right? In the changing quantum world, we are not able operating. Yeah, so these are the partners, and then there's some more stuff here. Quantum pioneers. Our team shares a deep passion for leading in the quantum race. We believe that this journey requires the best product, services and people. We are here to deliver that. Fostering customer-centric partnerships, we are champion customer-centric innovation, recognizing that true innovation is meaningful when it adds value to our customers' lives. We emphasize ownership, accountability and trustful relationships with our customers, suppliers and partners. And then there is something here about it, join us. Okay, then we see here the partners again, and I think that's about it, what we can see here on the page. I think that's also almost everything we need to know right now. Maybe one thing that I would be interested in also is like where the company is located. Let's see if we can find out somewhere here. Not sure. Let's see. Okay. Is there something else about the team? Get to know us. Okay. Oh, that's all the team members here. Also very nice to have all of them listed somewhere. Maybe here. Oh, maybe we see it when we open the LinkedIn page. Yeah. So Delft. Okay. Actually, I could have already known that, but yeah, always nice to check back to make sure that nothing is, that my information is not outdated. So with that, I think we've seen a lot about QBLOX. With that, I also want to wrap up today's video. As always, if you haven't done so yet, make sure to subscribe to the channel. If you have any other company that should be highlighted within this video series, let me know down in the comments below, and always stay hydrated. See you in the next one. Bye.